Hello and welcome to this lesson on interpreting box and whisker plots. We'll actually be making them as well. Just like the previous lesson was on stem and leaf plots and histograms, we're going to make them and talk about them. Did you know that each quartile, each kind of section of a box and whisker plot contains the same amount of data? Each has 25% of the data. So this piece has 25% of the numbers, this piece has 25%, and that one and that one. They all contain the same amount of data. What this tells you is where the data is chunked together and where it is spaced out. The smaller the quartile, the more squished the data is together. The wider the quartile, the more that data is spread out. But each section contains the same number of data points. This spacing and crunching is called dispersion. So you can see, like in this one, this data is really spread out. It might be 5 numbers in here. These 5 numbers are really spaced out, where the 5 numbers that would be in here are really close and compact together. Vocabulary, we got a couple. Box and whisker plot. Looks like that. This is a box and whisker plot. It's a way to organize data values into 4 groups. It's used to show dispersion of data. Your lower quartile is the median of the lower half of the data, and the upper quartile is the median of the upper half of the data. And that will make sense when we get to it. Interquartile range. The interquartile range is the difference of the upper and lower quartiles. So, to make sense of this, so here's a box and whisker plot. Boom. Oh man, I always do that. Throw them over here. All right. So this is your median. It is the number in the middle. This is called the upper quartile. It is the median of the upper half of the data. This is your lower quartile. It is the median of the lower half. You also have up here an upper extreme, and on the other end a lower extreme. Okay, so that makes a little bit more sense of these vocab words. Upper quartile, lower quartile. Now, the interquartile range, the IQR, interquartile range, is the difference between the upper quartile and lower quartile. Basically, it's this upper quartile minus the lower quartile. It's the range of this. What is the range from here to here? How spaced out are these values? That's the interquartile range. Inter means between, inside. Inside the quartiles, their range. And an outlier, as you already know, is a value that is widely outside the rest of the data set. He doesn't really fit in. But when you're talking about a box and whisker plot, we actually have a new kind of a technical definition. An outlier is, for a box and whisker plot, is a value that is 1.5 times the interquartile range or more away from the median. And we will definitely be doing problems talking about that and explaining and showing. Okay, but that's the technical definition of an outlier when you're talking about a box and whisker plot. So the very first problem, all we're going to do is make a box and whisker plot. We just want to show you how it's made. So you have a set of data. We need to find a median, a median, a median, the biggest, the smallest. Now, in order to find a median, it is very helpful if your data is in order from least to greatest. Now, this is not in order from least to greatest. So the very first thing I'm going to do is I'm actually going to put it down here probably somewhere, is I'm going to rearrange that in order from least to greatest. And I encourage you, maybe pause the video and try this on your own and just take your time with it. 173, 179. It's all the 170s, 180s. There's a 181. That's it. 198. And now we're in the 200s. 206. There's nothing in the 210 range. There's nothing in the 220s. There's a 230. There's a 240. There's two 250s, 251 and 257. Darn, I was hoping I could fit all of these in one row. I think I can if I squeeze them a little bit. There's a 261 and then finally a 295. All right, so I got them all in order. So now, you start with the median. You have to start there. So I want to find what is the middle number. Now there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is 11 numbers. Since that's an odd number, there will be one number in the middle. So what a lot of people do is they go like this, and I'm going to make my slashes really big so I can erase them. You don't want to completely cover up your numbers. So cross off the biggest and the smallest. Biggest, smallest. And you work your way until you find the number in the middle. I have 5 slashes bigger, or 5 slashes smaller, 5 slashes bigger, which means this right here, that is my middle number. That is the median. 239 is the median. First step, find the median. Now, once you have your median, you need to find your upper and lower quartiles. Your upper quartile is the median of this upper half. So you don't count this median that you found. So from these other 5 numbers, my upper quartile is the middle, the median of these 5, which is going to be this one, right? There's 2 numbers smaller, 2 numbers bigger. He's the one in the middle. That's my upper quartile. My lower quartile is the same thing on the lower side. So that's going to be, out of these 5 numbers, the one that's right in the middle is this 181, lower quartile. And then the extremes are just the biggest and the smallest. So 295 is the upper extreme, 173 is the lower extreme. Those are the 5 values we are going to use in making our box and whisker plot. Now, the next step is we need a scale on our number line. Our scale needs to go from, you know, around this area to around that area. I'm thinking counting by 25. So I'm thinking like if I start at like 150, 175, 200, 225, 250, 275, 300. That would work. I mean, I'm wasting a little space here, but I think counting by something different might be not as good, not as pretty. I mean, I might count by 30s. Would that be better? No, that'd be worse. 20s? 150, 170, 190, 210, 230, 250. 270, 290, 310. That makes it a little bit bigger. I don't know. I mean, how about I know. I'm gonna start at, instead of 150, I'm gonna start at 160 and then count by 20s. So 160, 180, 200, 220, 240, 260, 280, 300, 310, 320, 340. 16, 18, 20, 22, 24, 26, 28, 30, 32. I messed that up. That should not 310, should be 320, right? (24, 26, 28, 30, 32, 34, 36). There we go. So there's not a great scale, but it works. Now, we're going to take each of these 5 points, or those 5 points, they're the same 5, and we're going to plot them down here, not on our number line, down here in the middle of nowhere. Box and whisker plots, the actual box and whisker is not on the number line. So this is an estimation. So 173 is like here. I mean, this is 180, this is 160, so 173 is in the middle. And then 181, 239, 257. Oopsie, that should be over a little more. 295. Now, if you want, you could always do this whole thing. Like 295 would be like clicks right there. You go. So that kind of gets you more of a straight line, so you can kind of see where your values are. I missed, didn't I? You typically will not see these lines here. Okay, this is just to help you. So 273, 281, which actually I guess he's on the wrong side, right? Because 281 would be like here. 239 might be a little bit closer to 240. 257, yeah, sure. 295, sure. Okay, so it's just something to help you. Now, box and whisker. Whisker, whisker on the outside. The middle three get wrapped up in a box. And then you attach your median in the middle. That is a box and whisker plot from the data provided. And maybe I'll scoot them up just a teensy bit. Okay. We want to do the same thing. Now this time we have an added step of calculate the IQR, the interquartile range, then find what ranges any outliers would be in. Are there any outliers? So let's start with, I'm going to put my numbers in order from least to greatest. So we've got 14, 22, 27, 39, 45. I like to put my numbers right below the other numbers. That way I'll know if I missed one, because if I run out of numbers like here, I skipped one. If I have extra, it means I have extra. 50, 56. 64, 80, and 84. So you see how I have the exact right number of numbers? If I kept everything lined up, that's good. All right, so median. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. That's an even number, which means I'm going to have 2 in the middle. Those 2. 1, 2, 3, 4 bigger, 1, 2, 3, 4 smaller. These 2 numbers are in the middle. So the actual median here, there you go. The actual median is halfway between those. So halfway between 50 and 45, add them up, divide by 2, gives you 47.5. That is your median. Now, when you're finding your upper quartile and lower quartile, you do not count this median, but you can count this 50 and this 45. They're not your median. So on my upper side, I have 5 numbers, which makes 64 the upper quartile. That's the median of the upper half. Out of these 5, he's the one in the middle. I have 27 as my lower quartile. That gives me 84 as the biggest number and 14 as the smallest number. So let me see if I can squeeze all this somewhere. I want to have it there, but I don't want it to interfere with my box and whisker plot and stuff. All right. So now I have my values. They're here, they're here. We need a scale from 14 up to 84. So if I started at 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, sure, why not? Or even if I went from 0, 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, like that. Okay, so now putting our numbers in. Lower extreme, 14. I'm looking, there's 10, so 14 would be like here, but you put it down below. It's not on the line. 27 would be close to 30. 47.5 would be close to 50. 64 would be halfway between 60 and 70. 84 would be halfway between 80 and 90. Now, I'll be honest with you, before we graph these, we probably should calculate our IQR, because if this guy's like, say, an outlier, that's going to change our things a little bit. So let's calculate our interquartile range. So from here, the interquartile range is the upper quartile minus the lower quartile. So that's 64 minus 27. So any number that is within 37 of the median. So the median we said was 47.5. So if it's within 37 this way and 37 that way, it's good. If it's more than 37 away, then it would be considered an outlier. I know, I keep moving stuff. This is my IQR. I'm just trying to label, keep everything organized. So let's figure out. If I do 47.5 minus 37, if I get smaller by 37, that's 10.5. So if I had anything 10.5 or less, that would be an outlier. If I did 47.5 plus 37, that's 84.5. Man, that 84 that we had was almost an outlier. So from 84.5 or bigger is an outlier. Okay, so the outliers would be anything I did. Oops, no, I lied. Rewind what I just said. Okay, this is the interquartile range. The definition is it's 1.5 times the interquartile range, so 1.5 times 37. So 55.5 bigger and 55.5 smaller. So it's not just the interquartile range up and down, it's the interquartile range times 1.5. Is 55.5. So now if I recalculate, 55.5 plus 47.5, that gives me outliers would be from 103 and bigger. And then 47.5 minus 55.5, outliers would be -8 and smaller. So now we know where our outliers would be. Anything between -7 and 102 is good. Anything outside that range would be an outlier. So we do not have any outliers here. So now I'm making my box and whisker plot up above. Whisker, whisker, box, median. Okay, I want to talk through this because I messed up once and I'll make sure we're good. We found the interquartile range by taking the upper quartile minus the lower quartile. That is called the interquartile range, the range of the box, essentially. Something is considered an outlier if it is 1.5 times the interquartile range away from the median. So my median was 47.5. So if I went up 1.5 times the interquartile range up and down, that gives me my values that our outliers would fall in. And it's good to do this before you graph in case, for example, if 84 was an outlier, I wouldn't put him as a dot as part of the whisker. We will see an outlier within the next few problems. Okay, so if you could please, we're gonna do this step at a time. First, Could you pause the video and find your 5 values that would make the Box-and-Whisker plot? You don't have to do this part yet. We're going to do him next, but find these 5 values first. Hit play. We'll go through it together. Make sure you're good before we move on to the next step. Go ahead and do that right now. All right, so in order, we have 5, 8, 10, 14, 5, 8, 10, 14, 15, 27, oops, I missed 24, 24, then 27, 37, 40, 40, 47. Okay, those are my values. Median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which means there's an odd number. There's 1 in the middle, which should be him. That's 5 numbers bigger, 5 numbers smaller. He's the 1 in the middle. That's my median. The upper quartile is then the median of the upper half, not counting the median. So of these 5, the median upper quartile would be this 40. From the lower quartile, it would be the middle of these 5, being that 10. And then my extremes would be the 5 and the 47. Okay, before we do any graphing, let's calculate our interquartile range and see if there's any outliers. Interquartile range would be upper quartile minus the lower quartile, the box. So 40 minus 10, I didn't really need a calculator for that, is 30. Okay, that's my interquartile range. An outlier is 1.5 times the interquartile range away from the median. So 30 times 1.5 is, let me 45. So if something is 45 units away from the median, it's considered an outlier. So that would give me, let's see, from 24 is my median. If I go up and down by 45, what values do we get? So 24 plus 45. So anything that's 69 and bigger is an outlier. And then 24 minus 45 is negative 21 and smaller is an outlier. So now we can see that none of our things are outliers. They're all good. They're all between negative 21 and positive 69. So we can continue. So I would like you now to pause the video, make your scale, graph your Box-and-Whisker plot. Go ahead and do that right now. All right, so we've got 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That's like perfect. So 10, 20, 30, 40. I'm going to move some of these dudes up a little bit. There's no need for them to hang down so low. So we got lower extreme, lower quartile, median, upper quartile, upper extreme. I'm estimating where these values are here. There's 5, there's 10, here's my median of 24, upper quartile of 40, upper extreme of 47, whisker, whisker on the outside, box in the middle, and connect your median. Okay, letter D. So a small number of numbers, and the numbers themselves are fairly small. Okay, so let's see here. Order. In fact, I might be able to squeeze it over here. 3, 3, 3. There were 3 3s. 4, 4. 5, 6, 8. Okay, so there is 1, 2, 3, 4, 5, 6, 7, 8 numbers here. So my median, there's going to be 2 numbers in the middle. Both of these 4s are in the middle. So my median would be the number halfway between them, which is 4. I would add it up. 4 plus 4 divided by 2 is still 4. Now when I'm finding my quartiles, my upper quartile is the middle of these 4 numbers. I'm not counting the median, but I'm allowed to use him. 4, 5, 6, 8, which makes the upper quartile right here. 5 plus 6 divided by 2 is 5.5. The lower quartile would be the middle of these 4. Well, that would be halfway between here, which is still going to be 3. Now, the upper extreme being 8, lower extreme being 3. Now let's take a minute and calculate our interquartile range and figure out if there's any outliers here. So the interquartile range would be 5.5 minus 3, which is 1.5, right? 5.5 minus 3. That's the upper quartile minus the lower quartile. Ooh, I was wrong. 2.5. An outlier would be 1.5 times by the interquartile range, which is 1.5 times by 2.5, which is 2.5 times by 1.5, 3.75. So anything that is 3.75 away from my median, 4 is my median. If I go up 3.75, he's an outlier. If I go down 3.75, that's an outlier. Let's figure out what those values are. So 4 plus 3.75 is 7.75. So anything 7.75 or bigger is considered an outlier. And 4 minus 3.75 gives us 0.25. Are there any outliers? Actually, yes, we do. This 8 is considered an outlier. He is no longer our upper extreme. He's been kicked out of the club. Our upper extreme is now going to be 6. 8 is an outlier. So now, when we graph our data, yes, 8. When we graph our data, we're still going to need to include up to 8. Even though he's an outlier, we're still going to include him. But he doesn't get to be part of the Box-and-Whisker plot anymore. So check this out. 0, 1, 2. I don't know why I'm making these so low. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is fine. Lower extreme is 3. Lower quartile is also 3. Weird. Median is 4. Upper quartile is 5.5. Upper extreme is 6. So now let's look at this. So I'm going to have a whisker here, but remember I had 2 dots on top of each other here? Well, the whisker, it'd be like this if I could take these two and just kind of like really shrink them together so much that it's just going to look like 1 dot. Okay, so I'd be connecting these 2 dots together. They're already together. box around the 3 in the middle. Now what about that 8? So, by the way, see how he doesn't have a whisker? My whisker and my quartile are the same number. Median, upper quartile, upper extreme, outlier. We just throw another dot out here. He's an outlier. Sometimes you'll see the outliers as an X, but he's an outlier. So he does not get to be part of the Box-and-Whisker plot. Okay. Go ahead and see if you can make a Box-and-Whisker plot from these 8 numbers right here. You don't have to worry about the interquartile range or the outliers or anything right now. Just make your Box-and-Whisker plot. All right, in order, we've got 15, 20, 30, 40. I missed a 25. 15, 20, 25, 30, 40, 55, 60, 70. 55, 60, 70. All right, we have 8 numbers, which means my biggest, smallest, biggest, smallest, biggest, smallest, biggest. I've got 2 in the middle. Halfway between 30 and 40, I know is 35. I don't have to use a calculator for that. That's my median. My upper quartile is going to be between these 4 in the middle, right here, which is 57.5. That is 55 plus 60 divided by 2. Halfway between that is 57.5. My lower quartile is going to be the middle of these 4 values, not counting the median. So right here, which is going to be 22.5. And then the 70 and the 15 are my extremes. Upper extreme, lower extreme. Actually, I don't need circles around those. Those are my values. Now, we're going to take those values and we're going to make a Box-and-Whisker plot from it. Number line, 10, 20, 30, 40, 50, 60, 70, 80. 10, 20, 30, 40, 50, 60, 70, 80. Go back to black. So we got 15, 22 and a half, 35. I'm looking at these values here. So there's my 15. Here's my 22 and a half. Median of 35. Upper quartile of 57.5 is right about there. Upper extreme of 70 would be right about there. Whisker, whisker on the outside. Box in the middle. And that's a Box-and-Whisker plot. If you are curious about the interquartile range, 57.5 minus 22.5 gives us an IQR, interquartile range, of 35. 1.5 times 35 would give us outliers would be 52.5 away from the median of 35. So 52.5 that way, 52.5 that way, which none of these values are 52.5 values away from 35. So all of those values are good. There was no outliers. But in case you were curious and you wanted to know, there you go. All right, so that's done with making. Now we do a little bit of interpreting. Given a Box-and-Whisker plot, can we answer some questions? The following graph represents the gas mileage of 2 different companies of cars, each with 50 cars. Cool. Company A, Company B, we see cars, number line, looks great. Which company of cars has the least fuel-efficient car? What is that car's miles per gallon? Well, the least fuel-efficient here appears to be that. So, Company B and its miles per gallon seems to be around 15. About 15. Which company has the most fuel-efficient car, and what is that car's miles per gallon? Pause the video and do that one on your own right now. All right, you should have said Company A. And that car's miles per gallon is what, about 46 maybe? 46, 47, I'd go 46. It's a little bit bigger than 45, but not by much. But that company has the most fuel-efficient car. What is Company A's medium miles per gallon, and what is Company B's medium miles per gallon? Okay, well, Company A's medium is about, what, 38? And then Company B, their median, and this should not be medium, it should be median, I-A-N-I-A-N. Whoops. Their median miles per gallon should be 28, about. One for you. Same graph, same companies. About how many cars does Company B have that gets over 21 miles per gallon? How many cars do they have that gets over 21 miles per gallon? About. Pause the video and do that one on your own right now. Now, you may have struggled with this a little bit. This ties back to the very beginning thing we talked about, the very first page of the lesson, where it said that each section of the Box-and-Whisker plot holds 25% of the data. They all hold the same amount of data. So out of these 50 cars, we know that, we're talking about Company B, right? Yeah. There's 25 cars on this half, and there's 25 cars on this half. This is the exact halfway. This is the middle. So 25 get more than the median, 25 get less than the median. But we want to know about this number right here. So that would be how many? Well, it's 75% of the cars. What's halfway between 25? 12 and a half. So there's like 12.5 cars here, 12.5 cars there, and there, and there, which the half thing seems weird. I think that's why they say about how many. It's an estimation. You just got to be close. So about how many cars is this? That's more than 21. Well, that's 25. 25 plus another 12 and a half gives you around 37 to 38 cars. Which means that the other around 12 and a half, so 12 or 13 cars, get less than that many miles per gallon. Company B's graph is larger than Company A's graph. It's longer, it's wider. Well, what does that mean? What does it mean if the graph of a Box-and-Whisker plot is wider? Go ahead and pause the video, write down an answer. Okay, well, it means that their data is more spread out. The miles per gallon their car gets is more varied. It's more spaced out. It's not as compact. And that's it. It's just dispersion. It's more spread out. Their miles per gallon is more spread out. I can write spread out. Possibly the last problem for the day. The graph below shows the amount of rainfall for 2 towns in Texas over a year. So in this example above, for how many months was the precipitation in Dallas more than 2.6 inches? Go ahead and pause the video, answer the question. And the answer is 6 months. And how would you know? Well, this was over a year. So 3 months would be here, and there, and there, and there. Each section of the graph would have the same number of months. So they'd each have 3. That's 12 divided by 4 sections. And so 6 months, half of it was more than 2.6, half of it was less than 2.6. Summary. List the information you learned about box and whisker plots. You go ahead and make a list. What did you learn about box and whisker plots in this lesson? I guarantee there is something. All right, you probably learned that each section of the graph holds 25% of the data. Maybe you knew that. You probably learned the technical definition of an outlier for box and whisker plot is 1.5 times the interquartile range away from the median. You probably didn't know that. And the interquartile range is just the range of the box, the upper value minus the lower value of the quartiles. And so now we learned how you can find, an outlier. There was an outlier here and what that graph looks like. And then the rest of this was fairly easy. You could figure out how to interpret the graphs on your own relatively easy. Okay, so thank you so much for watching this lesson, and until next time, toodles.